Okay, please inform everyone to come quickly. We'll complete with the Boolean difference so that we have all the methods done for test pattern generation. Till now, we saw different methods. The first one was D algorithm. Then we had random test generators, followed by the path sensitization method, which we discussed yesterday. Now today we'll be doing this algebraic method, which is the Boolean difference method. When we say Boolean difference, we simply means partial derivative of the function fx. Let there be a function fx where there are multiple values like x corresponds to x1, x2, x3 and so on, say xn. There are so many variables. If I try to take the derivative with respect to one of the variable, let us say dxi. So d of fx with respect to xi, then for that variable I need to put two terms. One is once I have to put xi equal to 0. The other time I will put xi equal to 1 in the expression. So I will evaluate the function f when xi equal to 0. The other time I will evaluate the function f when xi equal to 1. Right? This evaluation of function at xi equal to 0 is sometimes written as f0 xi. So the value of f when xi is put equal to 0. When the function f is evaluated for xi equal to 1, it is represented as f1 xi. If I take XOR of these two terms, this is referred to as the Boolean difference or the partial derivative with respect to xi. So dfx over dxi is nothing but f0 for xi XOR with f0 for f1 for xi. क्योंकि XOR जो है वो कब ट्रू होगा, जब इन दोनों में से कोई एक फंक्शन ट्रू होगा. ईदर द फंक्शन f is 1 for xi equal to 0 or the function f equal to 1 for xi equal to 1. This is what we have learned कि अगर ट्रू वैल्यू 1 है तो फॉल्टी वैल्यू विल बी 0 और if the true value is 0 the faulty value will be 1. तो in either case एक ही वैल्यू 1 होगा. So this partial derivative is used to find out the test patterns for the stuck at faults. When I say I have to find the pattern for stuck at 0 fault at any wire xi, I need to multiply this dfx over this Boolean difference with xi equal to 1. Right? क्योंकि this Boolean difference and xi equal to 1 is the true value. Right? The fault is stuck at 0. अगर xi equal to 0 होगा then the multiplication will give you 0. Right? Then the resultant will be stuck at 0. Similarly, if I want to evaluate for stuck at 1 fault at xi, then the expression will be or the test pattern will be given as xi dash multiplied by the Boolean difference. Right? Stuck at 1 के लिए xi dash से multiply करना है, stuck at 0 के लिए xi से multiply करना है. For example, in this case, here g can be written as x1 dot x2 so that f can be written as x1 dot x2 plus x3. Fine. Suppose we detect fault at the wire x2 here. I can detect both the faults for the wire, but I need to find out what is dfx over dx2. The primary output is f, so I mean to differentiate with respect to x2 the value x1, x2 plus x3. ठीक? So So what does this mean? This means that I have to evaluate x2 plus x2 into x1 x2 plus x3 at x2 equal to 0 XOR, that is x1 x2 plus x3, evaluated when x2 equal to 0 XOR x1 x2 plus x3 evaluated at x2 equal to 1. In this expression, put x2 equal to 0. As soon as you put x2 equal to 0, x1 into 0 will be 0 because this is an AND. 0 or x3 will give you x3. Right? So x3 XOR. Here put x2 equal to 1. If x2 equal to 1, this will result into x1 plus x3. Now solve this XOR. This would be first expression as it is, x1 plus x3 ka bar plus x3 bar into x1 plus x3. Solve करने पर क्या आएगा? This will be x3 into x1 bar into x3 bar. So this will be 0 plus x3 bar x1 plus 0 because this would be x3 bar into x3. So the Boolean difference comes out as x1 x3 bar. Fine. To find the test pattern for stuck at 0, x2 stuck at 0, this pattern will be given as x2 multiplied by the Boolean difference, which is x1 x3 bar. This should be true. When will this be true? This will be true when the function x1 x2 x3 bar will take up value 1 1 0. So the test pattern which will detect the stuck at 0 fault at x2 is given as 1 1 0. Right? Stuck at 1 ke liye x2 stuck at 1, the test pattern will be given as x2 bar into the Boolean difference, which is x1 x3 bar. This should be true from this expression. Right? So this gives me x1 x2 bar x3 bar equal to 1, which is only true when x1 is 1, x2 is 0 and x3 is 0, which means the test pattern is 1 0 0 to detect stuck at 1 fault at x2, and it was 1 1 0 to detect stuck at 0 fault at x2. Right? Quickly looking at another example, we have an AND gate. Let's an AND. The input is x1. Another NAND gate, the output goes here, x1 comes here, and this is x2. Let us say this is f. So how will I write f? What is the output here? Let's call it g. G will be given as x1 x2 bar. Right? So what will f be? This will be x1 x2 bar into x1 ka whole bar. So that is x1 x2 plus x1 bar. Is it correct? Let us try to find the fault here. The test pattern to detect the fault at this wire. And let us call it H. This is the fan out. X1 has two fan outs. One goes directly to the NAND gate, the other goes to this NAND gate. So to find the stuck at 1 and stuck at 0 fault, I need to differentiate this f with respect to h, where h is nothing but x1. Differentiate this with respect to x1, that is, you put f0 x1 XOR f1 x1. Put x1 equal to 0, तो ये 0 हो जाएगा. This will be 1. Something wrong we are doing. H. Let's work with wire H. F is H x2 का bar into x1 bar. So this will be H इस पूरे का bar. This will be hx2 plus x1. So df over dh equal to f for h equal to 0, for f h equal to 1. Put h equal to 0, h equal to 0 होते ही x1 हो गया, x1 bar XOR. Put h equal to 1, h equal to 1 होते ही this gives you x2 plus x1 bar. Now correct. Take XOR. The first value as it is into x2 plus x1 bar ka whole bar plus the second value as it is into 1 ke bar ka bar. Solve this. This will give you x1 bar into x2 bar into x1 plus x2 x1 plus x1 bar into x1. So this gives you 0. This gives you 0 due to x1 bar into x1. So the Boolean difference comes out to x2 x1. To find stuck at 0 fault at h, stuck at 0 at h. So I should have h multiplied by the Boolean difference df over dh put equal to 1, which means h into x2 x1 equal to 1. H is nothing but x1. So this gives me x2 x1 equal to 1, which means the test pattern will be given as x1 equal to 1, x2 equal to 1. This gives me the test pattern to detect stuck at 0 fault at h. Now to detect stuck at 1 fault at h, stuck at 1 at h, I should put h bar into the Boolean difference, which is x2 x1 equal to 1. H is nothing but x1. So this means x1 bar x2 x1 should be equal to 1. This is never true because x1 bar into x1 can never be equal to 1, which simply means stuck at 1 fault at h is undetected. There is no test pattern which can detect the stuck at 1 fault at h. Right? There may be certain faults which are not detected by any of the test pattern. Even the D algorithm fails. The Boolean difference may fail since there exists no test pattern. Right? The circuits that we have done for Boolean difference, you can apply D algorithm to them. And the circuits for which we have worked with D algorithm, I will have, you can apply the Boolean difference to them also, right? Here we finish with this unit for test pattern generation. The next we will start with ATPG for sequential circuits. अभी तक हमने combinational circuits किए. The next thing tomorrow we will begin with sequential circuits. ठीक है? Any problem in today's lecture? Okay, one slide left. How to determine the quality of ATPG, automatic test pattern generation. We have already talked about fault coverage. Fault coverage we want as high as possible, which is simply defined as total number of detected fault upon total number of faults present in the circuit. When I calculate the total number of faults present in the circuit, this is before collapsing. No equivalence, no dominance has been calculated, and before collapsing, what is the total number of faults? Against those faults, how many faults are detected using any of the pattern, right? Fault efficiency is number of detected fault divided by the total number of faults minus the number of undetected faults. Undetected faults are removed from the fault list, and then we calculate the efficiency. We want the two terms to be as high as possible. Fine. This quality test is applicable for sequential circuits as well. Fine. Okay. That is all for today. We'll meet tomorrow and begin with the ATPG for sequential circuits. Those who have missed the class, they may look at the recording. Please see us, inform the students. They may look at the recording, and if we have any problem in this topic, we'll discuss it tomorrow. Okay, so I'm ending the meeting for today. You may leave.